Hello students and welcome to this calculus lesson. In this lesson, we're going to begin learning how to actually use our knowledge of integration to find volumes of solids. And specifically, these solids are going to be solids of revolution. So let's get started. So what I want you guys to think about here is if we have a function, let's of course name that function f of x or something. We're going from A to B. What ends up happening is we can make a rotation around this x-axis, or we can make a rotation around the y-axis. And what that's going to do is kind of create this model over here where it's going to have like a solid that gets rotated. So basically think of a solid piece of metal or wood that gets put onto this axis or this roll, and it creates this solid by spinning all the way around, kind of like in that video you just saw. Now, how can we use calculus to actually determine the volume? Well, the same way that we're finding area, and the way we're finding area is by finding like little rectangles, right? And we're adding all of those up. We're going to be doing the exact same thing here. So the basic thing that you want to keep in mind here is that we're going to cut these up into very, very tiny, slim discs, because what ends up happening is we're going to be getting a little sliver, kind of like what we are doing with Riemann sums. We're going to get a little sliver, and that little sliver is going to be this part over here. And when you think about it, you got to kind of shift your mindset a little bit. That's going to create what's called a disc, and a disc is just a very, very flat cylinder. And I have a little coin here. Basically, that's what we're doing. And when you take these coins of differing sizes, you can, this is a very thin coin. It doesn't really have much of a height, but it does have a volume that we can easily calculate via pi r squared times this height. And so then you turn it on the side here because it's getting rotated, and you have different size coins all the way through. You're going to add all those up. And what does that sound like? That sounds like integration. The only thing that you have to keep in mind here is that sometimes your axis of rotation might change. But if we wanted to simplify this a little bit, well, this pi is going to go to the outside. And notice here, this is exactly what we're looking at. Pi r squared times the height, except the height is this. That's going to be dx. And then the pi goes outside of the integral. And then we have r, all this is r, and then it gets squared. So pi r squared, and then the height are those little tiny heights, dx, the change in those x values. So oftentimes your x-axis is going to be your axis of rotation, and we're going to take our height from the function all the way down to the axis of rotation. But sometimes you kind of want to think like of a donut. Think about a solid that has a hole in going through the middle. So that hole does not have a part in the volume. So there are some times when it looks like this, where it goes all the way down to that line. And then what's going to end up getting created when we rotate this around this x-axis, well, everything that's in this area does not actually get calculated in the volume. We have to take that out. So we find that full volume, we're going to end up taking out this entire area right there. So how are we going to do that? What ends up happening after doing some simplification, factoring out, you end up with, so you have your outer function minus the axis of rotation. In this case, we're going to rotate around the x-axis. And then you have that all squared, and then you subtract the inner function minus the axis of rotation, and all of that gets squared. So let's look at this one here. Our outer function is going to always be the upper minus the lower. That's essentially what we're doing from our previous lesson. So our volume in this case is going to equal, of course, the pi goes outside, and we're going from A to B. Of course, that could be like 2 to 10, 1 to 5, whatever. And we're going to get, all right, here, f of x minus 0, because it's y equals 0. Don't forget that the x-axis is y equals 0 for that x-axis. So f of x minus 0 squared minus y equals c. So in this case, it's going to be c minus 0 squared dx. And so in our upcoming videos, what we're going to do is we're actually going to use these and looking at some samples. Of course, you're going to get a lot more review. You're going to see how they show up in free response questions or multiple choice questions. there's always going to be some sort of rotation question happening on the AP exam. So you're going to want to be prepared for it, but don't worry because this lesson is going to cover everything that you need to know. So stay tuned for the next video where we go over some examples. This is just an introduction. Of course, if you're confused about how this is supposed to look, reach out to me so I can give you some more resources or explain it to you in deeper detail. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.